Hello everyone, this is one of my numerical method videos where I'll try to explain you today how to use the inverse power method to find out the unit vector of a given vector and a given matrix and a given eigenvector, and to identify the dominant eigenvector itself. You know that power method and inverse power method are basically the iteration methods to identify the dominant eigenvector which has the maximum values in the eigenvector. So to find out the inverse power method, the formula I will use is this. So suppose the inverse power method Q I'll be using here and the formula is x03, which is the transpose of the given eigenvectors, times A, the matrix itself, and the eigenvector, divided by the transpose of a given vector again and the eigenvector itself. For example, so we will use this formula to use in the power method, inverse power method. So for example, let's say we have been given a matrix which is A 2 1 1 1 2 1 1 1 2 and an eigenvector which is 1 minus 1 and 2. We need to find x's of 1 and mu's of 1. Right, so now first we need to do what? We need to just understand how to get this transpose. So you know that x0, the eigenvector, is given as this way. Now the transpose of these would be just the horizontal of that, so which means it is 1 minus 1 and 2. Sorry, got it? Now let's plug in these values into the equation. So you have the equation x transpose of the eigenvector, which is 1 minus 1 and 2. Sorry, do not put a comma there. And we need to multiply with the main matrix, which is 2 1 1 1 2 1 1 1 2, with the given eigenvectors, which is 1 minus 1 and 2. That is divided by the transpose of the given vector, which is 1 minus 1 2 and 1 minus 1 and 2. So if you do the calculations now, so we will get, like if you do the multiplication of that, we may get 1 minus 1 2 and then 1 minus 1 and 2. I'm sorry, this should be 3 1 and 4. 3 1 and 4 if you multiply this. So then I have here, if you multiply these two, you know that 1 times 1 minus 1 times minus 1, 2 times 2, so that will give you 6. Okay, so now if you simplify more, you will get 5 by 3. That is your the value of the Q using this formula now. Okay, now what to do? Now you need to use this value, like you need to get the determinant. So your determinant is A minus lambda identity matrix, which means you just take your matrix and subtract each of them with this, which is 2 minus, your matrix is 2 1 1, so take 2 minus 5 by 3, 1 minus, and just keep this 1 and 1 and a half. Then you have 1 2 minus 5 by 3 and you have a 1, and you have 1 1 and 2 minus 5 by 3. Okay, and that gives you 1/3 1 1 1 1 by 3 and 1 1 1 by 3, right? And that is, so your unit vector the vector given was 1, -1 and 2. You need to normalize this. So you know how to normalize. You take the maximum of that and divide each of them. So your normalized vector will be half, 1 and half, and 1. Okay. So now what to do to find the y1? You do 1/3, 1 1 1 1/3 1 and 1 1 1/3. Remember this one we get from the determinant. Take that one and take the normalized vector, which is half, -half, and 1, right? And you just do the row echelon, reduced row echelon of that. So if you do the reduced row echelon of this, then you will get something like -3 by 28, 39 by 28, and -6 by 7. That will give you this reduced row echelon form of this vector multiplication. Now, this is in this eigenvector, you locate the maximum, which is this one, right? So what to do? Your mu1, which is this one, the eigenvectors with the maximum, the dominant eigenvector. To find the dominant eigenvector, what to do? Like you take (1 over -6 by 7), this one, okay, and add the value you got from your power method formula, which is 5 by 3. So you have 1 by -6 by 7 plus 5 by 3. Okay. So the lowest one of this reduced row echelon form plus the value you got from the formula of the inverse power method, that is giving you mu1. Okay. Now to get the x1, your x1 is basically the normalized y1, which means you divide each vector by maximum of reduced row echelon form, which is 39 by 28. So what I mean, so you have now x1 that gives you just take the y1, okay, and divide each of them by 39 by 8. So your y1 was this. So this is your y1, okay. You divide each of them by 39 by 28. So what do you get? You get, so you can do the rough division. For example, you know how to do this division. So 3 by 28, and you divide by 39 by 28, right? You just flip it, right? 3 by 28 times 28 by 39, that gives you -1 over 13. So this is how you find that. So if you divide this, you're getting 1 over 13, and then 1, and then negative 8 over 13. So that's your x1. So this is the unit vector you're looking for using the power vector, and your dominant vector is the value which is this, and this is your second answer or first answer, whatever, right? So to go for the x2 and y2 or mu2 or x2, you can do the similar thing again. You take the y2 now, like and take this vector again, and then you multiply with this one. Now, for example, like if you need to get the y2, excuse me, you take the this one, y1, and then you multiply with this new vector, that will may give you maybe 57 by 182 minus 237 by 182 and 102 by 91. If you multiply, you get this thing. And now use this to get your mu2. So your mu2 is 1 by the lowest one, which is minus 237 by 182, plus the one you found from the power method, which is 5 by 3. So take that. Okay, so that will give you your new mu2. And to normalize it, to get x2, right, you just divide each of this one, 570 by 182 minus 237 by 182 and 102 by 91 by the maximum of it. Okay, that will give you x2 again. So this is how you continue. If you need to find out the third vector and the third dominant vectors like x3 and mu3, you can use the same way to continue using the inverse power method. Thank you for watching it.